All right, we want to talk about half-life. This is physics part 5, half-life. Half-life is simply the time taken for half the original of something to decay or to disintegrate. So if you have a substance N, the time it takes for half of it, that's N over 2, N naught, N over 2. The time it takes, when the original is N, the time is 0. We have not said the time. For half of that thing to decay or to disintegrate, then the time that it takes from half of it decaying is what we call half-life. That is T half. And for the time it will take from that half of that thing to decay again is also half-life. The time it takes for half of that one again to decay is also half-life. So half-life is simply time taken for half of a substance to disintegrate. Then let's look at the curve, the graph of what? Half-life. The graph is coming down. It's coming down, going this way. So the graph is labeled, on the x-axis we have time. That is time. And then on y-axis we have the substance. So as the substance decay to half, this is the time it takes. As that half again disintegrate again or decay again, the time also is half-life. The same thing happen continuously. So as that happen, we're now looking for, we can now find a gradient. This is why I said it's very, very difficult to separate mathematics from physics, because it's not possible. So now we need to find a gradient. So finding the gradient is changing y over changing t. So changing y over changing t, as you can see. No, changing n over changing t, as you can see here. So now the thing is decaying, so it is a loss. So a loss in mathematics is negative. So change in n over change in t is what? A loss. So it's directly proportional to what? The number remaining, that is the n here. So to bring the proportionality constant, that is lambda, and lambda is the decay constant. So rearranging this, now for the change it will move to what? dn over dt. That's equal to negative lambda n. Negative lambda n. So rearranging, we have dn over n is equal to minus lambda t. So minus lambda t, you rearrange that, and this is under integration. So you integrate that. When you integrate, you have learned that ln a or log a minus log b is equal to log a over b. So a ln of this type of function, 1 over x or 1 over n, is what? Ln x. So we are integrating from n naught original to the n we have left now. So the n we have left now, yes, so ln n minus ln n naught is equal to negative lambda t half. Yes, rearranging that using the laws of logarithm, it gives us n over n naught. Rearranging that, we have something like that. Now ln, and we want to remove the log, that is the ln function. We introduce exponential function. So exponential function will come and take the ln away. So when exponential function comes, take the ln away. So we have n over n naught. That is amount remaining over the initial amount is equal to exponential function e exponent minus lambda t half. Rearranging that, we have the final answer as the n remaining at any time t. So n of what? T. N as a function of t. Yes. is equal to n naught e exponent minus lambda t half. That is what we call decay law, or somebody will say let's call it activity law. So radioactivity or activity law, that is A amount remaining now is equal to the initial amount times E exponent minus lambda T half. That's the decay law. Then now let's talk about half-life. Let's get the equation relating decay constant and the half-life. So now when n is disintegrating, move from n naught to n, we have n the same, so we can now divide them. So the n here, the n naught here will cancel the n here. We have half. 1/2 is equal to e exponent lambda t half. Then taking the logarithm of both sides again, we have log of 1/2 is equal to log e exponent minus lambda t half. As we have agreed, or we have learned the laws of logarithm, log 1 to any base is equal to 0. Therefore we have log 2 minus log 2 is equal to minus lambda t half. Then minus here will cancel the minus here. We have log 2 over lambda is equal to lambda t half over lambda. So cancelling this will give us t half is equal to log 2 over lambda. And log 2 over lambda, log 2 is 0.693. So now to calculate the time when the decay constant is given, to calculate the half-life is given by 0.693 over lambda. When lambda is known, half-life can be calculated. When half-life is given, lambda can also be calculated. So this particular law, you need to know it thoroughly. Or the activity law. If you know the activity well, you want to know the amount remaining at the end of a certain half-life, then that amount is equal to the initial amount e exponent minus lambda t half. When those things is given, then you will be fine. So n as a function of time is equal to n naught e exponent minus lambda t half. Thank you for watching. Please like, comment and share. Watch out for part 2 where we solve more questions.